If you've ever launched a Power app and braced yourself for users to find the bugs, you're not alone. But what if the myth that low-code apps don't need automated testing is the single biggest risk to your business data? Today, we're breaking down why robust testing is more urgent than ever in low-code ecosystems and the surprising ways automation tools fit into your Power Platform strategy. Why low code means low risk is the most expensive myth in IT. If you've ever heard someone dismiss issues with, it's just a Power app, how complicated can it be? This mindset is still everywhere. Teams roll out Power apps as fast as new ideas pop up. The thinking is straightforward. If a platform is designed so anyone can drag and drop their way to an app, why would you need rigorous testing? It's easy to assume that because low code promises speed and simplicity, actual errors must be rare, benign, or easy to fix after the fact. The trouble is, reality has a habit of ignoring our expectations. Let's say a team is using Power Apps for invoice processing. Everything looks clean in their preview sessions and UAT walkthroughs. A few months later, accounting finds invoice totals coming up wrong. At first, they blame user error, but the trail leads back to a schema change. Someone updated a money field to text, broken integration, and the app started pulling in malformed numbers. No error messages, no dramatic failure, just a quiet building stack of small mistakes that turns into a data reconciliation project no one saw coming. The app, once just a simple tool for entering numbers, has become the root cause of both financial confusion and late nights for every analyst downstream. These stories aren't just urban legends. In 2022, a global retailer lost 3 days worth of customer order data after a migration to Dataverse. The culprit? An untested formula in a low-code field mapping routine caused silent data drops. Compliance had to scramble because personal customer data vanished from the required audit trail. The harsh reality is the pattern repeats. A small schema update, a missing rule, and suddenly you're not looking at a drag-and-drop project. You're untangling a production incident. You'll find this pattern in all sorts of environments. Why is the myth so sticky? For one, the marketing tells us Power Platform is citizen developer territory. The apps look approachable. There are no curly braces or cryptic stack traces. But look under the hood and there's a second reality. Every simple app has connections to data in Dataverse, to SharePoint, maybe to Exchange mailboxes, or even SAP via connectors. Data flows don't show up on a user's screen, but they drive everything under it. Think about how even a single incorrect mapping in Dataverse can ripple out. A change table in your Power App might mean Teams approvals go missing or Outlook task creation fails quietly in the background. Power BI dashboards built on Dataverse data may show the right metrics until a silent error flips a flag behind the scenes. What seemed like one isolated data point is actually part of a bigger mesh of systems talking to each other, and a single missed validation test is where things unravel. It's not that Power Apps are more fragile than traditional apps. It's just very easy to believe they're so straightforward, you don't have to think about the risks. Let's step back for a second. Looking at research from enterprise IT analysts, you'll see a repeating warning. Hidden risk is everywhere in low code. According to a Forrester survey from late last year, 57% of organizations using low-code platforms reported at least one major production incident traced back to a missed testing step. The most expensive ones were always the quietest. Nothing dramatic at deployment, just a slow buildup of problems from unchecked dependencies, silent data loss, or integration drift. All of it was preventable with the right tests. What's deceptive about no-code or low-code platforms is how much complexity hides underneath. Every time you add a new connector, tweak a formula, or grant a security role, you layer in another invisible rule. The Power Apps designer hides the technical scaffolding, but Dataverse enforces its own business logic and security boundaries, and connectors have their own update cycles. What your business users see as a nice drag-and-drop interface is just the front end of a much larger, fast-moving engine room. Change sets aren't isolated. They cascade across anything tied back to Dataverse. It's why a tweak to your vacation request app can suddenly foul up workflows in HR, break data sharing with partners, or expose fields never meant for all users to see. Skipping robust testing on these apps is like assuming a car with a nice paint job doesn't need brakes checked. The real trap isn't thinking Power Apps are less powerful. It's acting like you can cut corners just because the build process looks easy. The cleanup always costs more than doing it right in the first place, and you don't realize the hidden complexity until the pain lands in your lap. So if simple on the surface makes us lazy about testing, there's a much bigger problem lurking beneath. The idea that low code makes mistakes impossible is really just the belief that it's safe to skip the hard work of validation. And every time someone tries it, they're surprised at how expensive that shortcut gets. Why then do faster builds actually lead to harder testing? Let's talk about how the very thing that makes Power Apps feel easy is exactly what introduces more risk behind the scenes. The hidden complexity, why drag and drop apps need smarter testing. Let's be honest, a lot of Power Apps projects start with someone just wanting to make life easier for their team. Drag in a gallery, connect it to a Dataverse table, add a few logic rules, hit publish, and suddenly what started as a side project is on the shortlist for critical business application of the month. So it's fast and feels low maintenance, and that's what draws people in. But every extra card you drop in, each new form, field, or rule you add, you're piling on layers of connection and dependency that aren't obvious from the app designer screen. The problem isn't building the first version, it's what happens when that weekend project outgrows its training wheels and starts handling approvals, secrets, or compliance-driven workflows. See how quickly you can go from a simple vacation request tracker to something that carries HR data and approval histories for the entire company. Think of a vacation approval app. The basic version allows employees to submit requests and managers to approve them. It works fine in a controlled environment, at least that's what teams discovered during the initial testing rounds. But as soon as more departments come on board, the business owner tweaks the schema so finance can see extra fields, maybe adds a new table for tracking time off balances, or creates a shortcut for executives to approve multiple requests at once. Permissions get shuffled, and without anyone realizing it, a field with sensitive information is now visible to people who were never supposed to see it. No error popped up. The only test was a few checkbox clicks by someone in HR who happened to have all the right permissions for everything anyway. The privacy leak only gets caught when someone runs an internal audit weeks later, and by then it's a real issue. Microsoft's own documentation admits that the underlying architecture here is anything but simple. Apps are built on metadata-driven forms, dynamic user interfaces that adjust based on the current user role, environment variables, and a set of ever-changing connectors talking to cloud services. That means what you see in your Canvas app or in your Power Apps Studio preview is only a guess at the final user experience. User A and user B might see entirely different screens and different data based on their security context in Dataverse. Add environment variables into the mix, and suddenly an app that worked in dev starts breaking in QA just because a third-party connector is pointing to the wrong instance or a key has been rotated. And here's where it gets tricky for testing. Nothing stays the same for long. Update a date field to allow nulls. That could break a Power Automate flow linked to the app. Change a permission set so an external partner can use the app for processing. Whoops, now your lookup field is visible to everyone. Controls in these apps frequently use conditional formulas. You think the right field hides for users without manager in their job title, but the logic gets bypassed after someone tweaks a business rule elsewhere. Now, you've got an edge case that would never show up in a basic checklist or a demonstration walkthrough. Manual testing can catch some of the obvious stuff, but it's shockingly easy to miss the subtleties. The most common method is to ask business users to try out new features or run through a couple of happy path scenarios. The trouble is, nobody actually lives on the happy path in production. Real users trigger weird conditions. Expired licenses, revoked permissions, inconsistent data between environments, connectors that suddenly start failing after a silent update from Microsoft. Manual testers do a great job within the boundaries of what they know. But Power Apps being so flexible invite complexity, branching logic, if then else formulas, dynamic controls tied to data that can mutate mid-session. You can't manually test every combination, especially when every department wants their own tweaks and a new integration gets added before anyone finishes regression tests on the last one. Take environment variables. They sound harmless, a handy way to swap resource links between dev, test, and prod. But change one in the wrong environment, and the app points to a stale SharePoint site or pulls sensitive financials from a sandbox with weaker security. It could even be as simple as a connector to SAP failing because an authentication certificate expired, something not obvious during QA because the test credentials were still valid there. There's no checklist for that level of context-specific, always shifting risk. Traditional QA checklists break down here. The Power Platform isn't just build once, test once, done. It's build, change, customize, integrate, change again, publish, and hope nothing explodes. There's no way to script out every scenario using traditional user stories because every app is part of a moving network of dependencies. You can't just run through a few happy path forms, check off fields, and assume coverage. The flexibility that makes Power Apps so useful turns them into experiments with unexpected results each time something small changes under the hood. If we know manual testing and the usual QA playbooks can't keep up, what's left? The reality is every untested update is a little roll of the dice. Unless your team has a reliable way to simulate user roles, dynamic data, and ever-changing connections, any release can break things nobody thought to check. That gap is why automation isn't nice to have. It's the only real defense against the growing shifting edge cases that come with high-powered low code. That brings us right to the next question. If these apps are so tricky, are we just stuck wiring up generic Selenium scripts, or have Power Platform teams built tools that actually understand this world? Let's drill into the real options for automated testing in Power Apps and Dataverse. Beyond manual testing, how automation tools like EasyRepro and Packed CLI changed the game. If you've ever finished a release and thought, well, we tested it, hopefully nothing slips through, you understand how manual testing can lull everyone into a false sense of security. Most teams still depend on user acceptance testing. The thinking goes like this: if our business users kick the tires and nothing explodes, it must be solid. But business users only check the features they care about. One user will open the app as an HR manager, another as a standard employee. Each of them sees certain screens, fields, or actions, never the full picture. They log in, try what's familiar, and report back. It feels thorough because everyone signed off, but nobody tests as a finance admin with restricted rights or as an external vendor who lands on a customized view. That leaves loads of edge cases sitting in the shadows, especially as the Power App grows past its original scope. I've seen the missed bugs that crop up when an app built for 20 people suddenly gets rolled out to 1,000. UAT might catch the obvious stuff. The button doesn't save, the form doesn't load, but what about the field that toggles based on user role or the dropdown that loads dynamic values from Dataverse? When those things break, only the right combination of inputs and roles even triggers the bug. Traditional QA tools struggle with this. They can't see the metadata-driven magic that makes Power Apps so flexible. If you hand a Selenium script a model-driven app, it'll choke on dynamic controls or throw errors for conditional components that only pop in based on data in the user's session. That's why bugs slip through, hiding behind complex formulas, complicated permission trees, and security rules that nobody can demo in a 5-minute screen share. This is where Microsoft's EasyRepro hits a sweet spot. If you haven't used it, picture a framework purpose-built to test real Power Apps. Not just click around, but actually simulate a live user with all the right roles, business rules, and authentication flows in place. EasyRepro scripts are like miniature end-user robots. They can log in as an HR user, a sales rep, or a custom security role you defined. You tell the script what the user should see. Fields hidden, sections locked, forms behaving differently based on stage business rules firing when data is out of range. I've watched EasyRepro surface bugs that nobody on the business side thought to check. One team at a healthcare nonprofit built a model-driven app for case tracking. They were certain that sensitive notes were accessible only to case managers. EasyRepro tests running every night revealed that a permissions update accidentally exposed a notes field to temp staff, something manual testers never noticed since they weren't logging in with those credentials. The fix was quick, but the real win was catching an embarrassing privacy issue before go live. EasyRepro also handles data validation. Manual UAT might spot if a form errors out, but it won't catch subtle broken business rules, like a workflow that should block submissions with out-of-range dates or missing attachments. EasyRepro can poke every inch of the UI, trigger those same business rules, and fail the test if validation logic even slightly drifts from expectations. The framework also works natively with Dataverse metadata, so it won't fall over when you change a form layout or add a new security layer. That's a level of test depth you'll never get from generic browser automation. The Power Platform CLI, or Pack CLI, is another tool that's been a game changer for test automation. Unlike EasyRepro, which simulates users, Pack CLI lets you script and automate end-to-end testing tasks from the command line. Need to spin up a fresh Dataverse environment, deploy a solution, reset test data, and kick off a suite of automated functional tests? You can do all of this in a repeatable pipeline. No need for a full-time DevOps engineer on staff. Pack CLI hooks into your existing CI/CD tools. So every time you push a change, it can fire up a battery of tests against your real app with all its connectors, flows, and business logic intact. It isn't just limited to UI tests. You can check solution imports, environment variables, role assignments, and even data integrity without having to jump through hoops. Let's talk specifics. A mid-sized regional bank migrated their credit approval process to Power Apps and Dataverse. They worried about edge cases like approval step changes and varying role permissions causing accidental rejections or approvals. Before go live, they set up nightly easy repro scripts to run all possible approval scenarios for every user type. One test flagged that regional managers saw an override button that should have been hidden. The automated run caught it within hours of the update. Fixing it before launch spared them a round of regulatory questions and a massive support headache. The scripts keep running today, so every change triggers a full regression test on the business logic and field access. No guessing, no crossed fingers. What separates these tools from legacy approaches is their deep tie to Dataverse. They don't just mimic button clicks. They respect business process flows, pick up on metadata updates, and understand Dataverse security roles. Easy Repro recognizes when business rules should fire and fails if they don't. Pack CLI knows how to deploy connected components, run them in realistic scenario sequences, and report specific errors with context. The old one-size-fits-all web testing model was never built for this kind of complexity. So automated testing for Power Platform isn't just a productivity bonus, it's a critical safety net, one that gives you actual confidence in what goes live. The cost of building out those scripts is a fraction of what it costs to find a business logic error in production. And as your app connects to more systems, that safety net just gets more important. Now, the next problem, Dataverse itself. Can you really treat it like a normal database and expect these automated tests to cover everything? Or is Dataverse a different animal with its own set of testing puzzles? Let's make sense of that next. Testing Dataverse, why database testing isn't enough anymore. If you've ever tried to apply your old database testing know-how to Dataverse, it probably felt like fitting a square peg in a round hole. On the surface, Dataverse acts like a relational database. You've got tables, columns, rows, relationships, and yes, you can query it with TDS or OData. But if you scratch the surface, you start to realize it's much more than that. When folks ask if they can reuse their existing SQL test scripts or lean on data unit testing, they're missing everything that actually makes Dataverse powerful and risky. The thing is, Dataverse isn't just a pile of tables, it's also a rules engine. Every field can have its own business rule, plugin, calculated formula, or workflow attached to it. Change a record in Dataverse, and that update might kick off a flow in Power Automate, invoke a plugin that alters another record, or even start something over in SharePoint or Teams. It's an integration hub sitting in the middle of everything from mobile apps to reporting dashboards. If you only test the underlying data, you leave all of those rules and integrations to chance. Let's use something real. I saw a scenario where HR wanted to tweak a field on their employee table, just a renamed column, nothing major. What they didn't realize was that a Power Automate flow depended on that column. The new field name meant the flow started failing in the background. Even worse, that flow was set up to push changes to a SharePoint HR log for 3 days. Any updated employee records were quietly dropping out of the SharePoint sync with no alert. Nobody noticed until someone tried to run a compliance report, only to find huge gaps in the data feed. The core problem? They wrote tests around database CRUD operations and schema integrity, but never validated the business logic, the flows, plugins, and the integration bridges to other platforms. This is where Dataverse's security model throws another curveball. You have row-level security, team-based access, owner fields, business units, and granular permissions at both entity and record level. In a simple SQL environment, you might check if a user can select, insert, update, or delete on a table. With Dataverse, it matters which security role a user has, which team they're in, and whether you've layered multiple access levels through the UI, solution layers, or even custom JavaScript. That means one test user could see a button or a record while another, logged in with the same credentials but from a different business unit, sees nothing. That's nearly impossible to check with a basic data-driven test. You see the same complexity in business rules and process flows. Anyone who has built a business process flow on Dataverse knows how quickly things get tangled. Each stage can unlock or hide fields, trigger plugins, or even call Power Automate flows. If you test the table data but ignore these flows, you'll miss things like a plugin blocking updates after a specific step or a workflow accidentally exposing fields when a record enters a new status. These aren't just minor glitches. They're the kind of problems that show up weeks later, often after an update in another system. That's why database-only testing tools feel out of their depth. They can check that contact records follow a schema or that you can't insert text into a money field, but they can't exercise a business process flow from start to finish. They can't impersonate users with different roles or check if a plugin fires at the right stage. And forget about monitoring external triggers. None of it shows up in a classic database test suite. This is a problem when half your business logic and risk lives outside the table definition. What does work is building custom test harnesses tailored to your app's logic. For Dataverse, this means scripts, or better, automated test runners that create records, walk them through business process stages, and check the outcomes. You want to simulate different user roles, trigger workflows, and verify that the correct plugins and Power Automate flows respond the way they're supposed to. For instance, if a plugin is supposed to set a flag when a record enters a specific status, your test shouldn't just look at the database, it should run the scenario end to end and confirm the flag only flips under real-world conditions. It's the same story with external integrations. Many business-critical Power Apps count on Dataverse to connect with everything from Teams to SAP, often by way of flows or API calls. A solid automated test regimen doesn't just check the data after the fact. It steps through the business flow, pings the external service, and asserts the right data landed where it was supposed to. That means tests aren't just about inserts and updates. They're about orchestrating scenarios, role impersonation, and validating side effects across platforms. At the end of the day, Dataverse testing is application testing, not just data testing. You need automated coverage of everything in the application context: business rules, plugins, flows, user access, and external triggers. Basic unit tests and data integrity checks simply won't keep up. And as more of your systems hang off Dataverse apps, bots, dashboards, integrations, the cost of a missed bug multiplies. Standard database tools leave holes you don't even see until they become production incidents. All this really changes the ROI discussion for test automation. When proper testing covers business processes, integrations, and security, you're not just protecting the data, you're protecting the whole engine driving your apps. The hidden cost isn't in the extra automation work, it's in cleaning up chaos when the blind spots finally show up. Knowing that, how do you actually measure the value of automating these tests for Power Platform? It's not just about fewer bugs. Now it becomes about business stability, trust, and the kind of control slow manual testing never really delivered. If you've ever woken up to a system alert that shouldn't exist, you know what's at stake. Automated testing in Power Platform isn't some luxury for teams with spare time. It's what keeps your business apps from breaking at the worst possible moment. Robust test coverage gives you room to experiment, ship features, and sleep through the night. Skip it, and even the basic apps can bite back. So next time someone downplays a Power App and questions the test effort, just point to the weekends you spent handling emergencies that shouldn't have happened. Testing is about trust, and that's what matters.